Good to go.
All right, good afternoon, everyone. So my name is Jingjing. I come from Indiana University. I work at the business school. So therefore, the paper that I'm going to discuss today will be a little bit different from some of the papers that you have heard over the last few days. So in this paper, we take a behavioral perspective and we study the preference biases in recommender systems. I think for everybody attending this conference, we all know that the feedback loop inside recommender system is very critical for the success of those systems. So basically, the system make prediction of user preference, and then based on that, we make recommendations to our consumers. And consumer will then choose some items to consume, and after consumption, they will form their own judgment of how much they enjoy the item, and they provide their post-consumption ratings or feedback to the system. And those feedback will hopefully help the system to improve their recommendations in the subsequent rounds, right? So this is a feedback loop that we have been talking about for the last number of years. But here, one critical assumption that we often implicitly make is that the user's post-consumption feedback rating represent users' true preferences for those items, right? So we often use that as a ground truth, that's a holy grail. And therefore, for the evaluation of the recommender system, as the previous two speakers already talked about, we often try to compare how well we are able to predict what user would enjoy the system. So basically, we compare the predicted rating versus the user submitted rating, and we use that to evaluate how well the system is. But in our research, we try to step back and we ask ourselves, is our assumption really hold? Does it really hold, right? Does all those feedback rating provided by system truly present the user's true preference? And over the years, my co-authors and I, we have looked at these issues. We have conducted numerous experiments. And what we found is that a lot of times, users submitted ratings actually have inherent preference biases. And these preference biases are induced by the recommendation that they receive before they actually make the consumption, okay? So you would think that pre-consumption, those recommender systems should affect users' consumption choices. However, after they have already consumed the item, so they should form their own judgment of those items. But that's not the case. So we found that suppose that the user's actual rating for a given TV show is 3 stars, but because we present a high recommendation with this item to the user, and this high recommendation will actually serve as anchor, and which will pull people away from their true preference. So now, instead of submitting 3 stars, they will submit higher ratings for this item. And we found this is true on the lower end as well. When users see a low recommendation, they will actually think they enjoy the item less, okay? And therefore, their preference ratings for those items will be lower than their actual preference. And this is a critical issue because we all know that recommender systems are not perfect, right? So they have inherent errors in the perfection. So in those predictions. So therefore, all those inherent prediction errors will induce preference biases in users, and those biases have a lot of unintended consequences. So they will contaminate the input data that the system gets, and they will also provide us a distorted view of users' true preference for those items, as well as an inaccurate view of the system's performance from the evaluator perspective. So over the years, my co-authors and I, we have developed a research stream that we look at these issues, and we have published a lot of papers in this research area. And the one that I'm going to present today is a recent paper that we published in MS Quarterly. And in this paper, we try to look at the biasing effects of different types of recommendations. And we all know that there are many different types of recommendation. There are personalized recommendation. There's non-personalized recommendation. Often comes in the form of aggregate ratings, right? So those recommendations can display similar, have a similar display. So for example, I have some screenshots here, and some of these are personalized recommendations. Some of them are aggregate ratings. So they have similar format, similar display, but they essentially represent two very different forms of information, okay? So for aggregate ratings, they represent a signal for the item quality provided by the online community. So from the way the aggregate user rating affect our decision making is through social influence. So through social comparison, through identification, through learning from other people's behavior. Okay? So through the social influence, the aggregate ratings affect our behavior. On the other hand, personalized recommendations usually don't have a social component or explicit social component attached to it. And therefore, they actually serve as an informative, individualized piece of knowledge. User will incorporate them in their information integration process, and when they try to make a cognitive assessment of the quality relative to their unique taste. So they affect the users through very different mechanisms. So the question for us here is, do they affect the user in a similar way? Do they introduce a similar level of preference biases in users' post-consumption preference ratings? So that's the research question that we try to address. And then we look at three aspects. So the first one I'm looking at is when they are presented separately, okay? So do those average ratings have similar biasing effects compared to our personalized recommendations? The second question is, well, a lot of time we see those ratings and recommendations presented jointly. So when they are presented together, then how do those, which one is more influential, which one is less influential? And what is the combined effect of presenting both information to the users? So we studied those three research issues in this paper. And we have conducted lab experiments, randomized lab experiment, in which we invited our participants to come to the lab, and then we give them 100 jokes. So the first 50 jokes, we ask them to provide ratings without kind of read the joke and provide the ratings. And these ratings were used to seed the recommendation system. And then we also ask them to read the rest of the joke, and then those jokes will be displayed either with aggregate rating or personalized recommendation or both. Okay, and when we measure bias, we use this well-established bias metric where we compare the user preference differences when they see a higher rating versus when they see a low rating. If there is no bias, then we then obviously don't see a statistical difference between the two. So the first study, we look at the case when user ratings and the personalized recommendations are presented separately. So they only observe either one of them, and we try to see the relative effect size of the two. So with between subject, we have randomized the classification whether they see aggregated rating or they see only personalized recommendation. Within each subject, we give them 20 random ratings. That is very kind of high random ratings. 20 jokes comes with low random ratings, and we also included 5 with medium random ratings just to make it a little bit more realistic from the participant point of view. And then because we randomized, assign the people to different groups, we don't kind of have a statistical difference in terms of the participant characteristics. And I have included some screenshot from our experiment. So the participant either saw the aggregate rating or they saw a personalized recommendation attached to each joke. And we performed a simple comparison using statistical tests to see whether high versus low ratings will have different user preference. And we found that's indeed the case. When users see high ratings, whether it's personalized or aggregated rating, they will rate the joke highly, okay? Even though those recommendations are just random numbers that we generated. And we also compare the size, the biasing effect size of personalized versus non-personalized ratings, and we found that they are statistically the same, okay? They are not different. we also followed up with a regression analysis because we have repeated measures, so we were able to construct a panel data and use econometrics model to evaluate the effect size kind of by controlling a lot of those variables. And we found that there is no statistical difference between aggregate ratings and personalized ratings in how much they influence users when presented separately. Okay. And so that's study 1. In study 2, we further look at the combination effect. So we display the ratings together. So each user saw 2 things. For each joke, they saw 2 things. One is aggregated rating, the other is a personalized recommendation. And again, within subject, we give them 10 with high, and then 10 from high, low, and 10 from low, high, and then 10 from low, low. We randomized the order of the aggregated rating and personalized recommendation. And this is a screenshot. As I mentioned, they both, for each joke, they saw 2 pieces of information together, but we randomized the order of the 2, which one displayed first and which displayed later. And again, we kind of started with statistical test, and then we look at when those ratings agree with each other, so when they're both high or when they're both low, okay? And we saw that there is a statistical difference between high and low. However, those combined effects is not necessarily larger when they only saw 1 high rating. Okay, so showing 2 high rating doesn't really make them rate even higher than showing 1 high rating. So there is no additive impact by combining those 2 pieces of information to the users. And then we also look at the case when the ratings conflict with each other. Okay, so when one is high, the other is low, then which one is more influential? And we compared the effect size, and we found that when both information are displayed together, when they disagree with each other, then in those cases, personalized recommendations take the driver's seat, and it's driving the impact. And then the aggregated rating take a back seat. So that means personalized recommendation is is a dominant one, dominates the impact. And we followed up with more rigorous analysis, statistical analysis, and as we expected, the order did not matter, and then those 2 did not have additive effect, but they have a separate, like a different effect bias effect size when presented together. As I mentioned, personalized takes the driver's seat. Okay. And we further pooled the study 1 and study 2 data to further statistical test whether there is additive effect. And as I mentioned earlier, there's no additive impact. Okay. So that's kind of the 2 studies. So to summarize, they both aggregate and personalized recommendations have biasing effect. They are not statistically different. When they are presented separately, they have similar impact. When they're presented together, personalized take the driver's seat, and there is no additive impact. And this is ongoing research. We have kind of some ongoing project, and these are my awesome co-authors who unfortunately could not be here, but I still want to acknowledge the contribution to this paper. So thank you. I'm open to questions.
Thank you so much for the presentation. Time for questions. Questions? Okay. I would like to ask you something. So you quickly went through the next steps for the thing. So could you just summarize like what the next steps are planned for the research?
This page?
Yeah.
So here I give 2 examples of the 2 papers that we're currently working on. So the first one, we are looking at persistence of biasing effect. So far we have only looked at the biasing impact in a static setting, but we don't know how long they will last. And in the first paper, we actually saw that they can last up to 7 days. So after receiving a recommendation, after I consume it, after even 7 days, if you ask me again how much I enjoy the item, my answer is still biased by the information that a random number that I saw 7 days ago. And the second question that we're studying is the longitudinal dynamics of preference biases and how they influence recommender system performance. And so this paper, we found that the preference biases cannot be self-corrected. So as you can expect, so sometimes we overpredict, sometimes we underpredict. So maybe there is self-correction over time. But we found that when bias is high, is like more than 50%, then there is no self-correction. But if bias is less than 50%, then there is a chance to self-correct over time. And we also found like certain items are more susceptible to the preference bias. So the less popular ones and also the less distinctive, less unique items tend to be more influenced by the preference biases. Okay.
Thank you so much for the explanation. We have a quick question on Slido. We will try to be very quick about it. So the personalized recommendations you refer are predictions that come from the ratings given previously by users? So the personalized recommendations?
The personalized recommendations are generated by recommendation algorithm based on what user have rated it previously.
Yeah. Okay. So thank you so much for the presentation. Now